Well, welcome. This is still Biomedical Core Health Sciences 1110. I'm still Jim Hutchins, and just to remind myself today, I wore a shirt that actually has my name on it. It was made by my good friend Jane Weedland, who is actually on my bowling team. Another story for another day, but you may remember Jane Weedland as the guitarist for the 1980s band The Go-Go's. And we're on Module 5 now. Module 5 is going to be molecular biology, and I'm going to start with a fairly lengthy story about molecular biology, which you can skip over if you don't want to hear about molecular biology and the history of molecular biology and why we're having such a struggle with molecular biology, why people, I believe, have a hard time with it. Then you can skip. But I think the problem with molecular biology and the reason that people find it hard is what I would call the original sin of molecular biology. You may or may not know that in the early 1950s, an American and a British scientist by the name of James Watson and Francis Crick, respectively, were credited with discovering the structure of DNA, discovering what we now know as the double helix. And in fact, Jim Watson wrote a memoir called The Double Helix in the late 60s based on the Nobel Prize that he won and how he got to win the Nobel Prize for this wonderful work that he had done. Well, Jim Watson would like you to think that he's a great intellectual, but in fact he's an insufferable tool and one of the most difficult people I've ever had the displeasure of knowing in or out of science. And Jim Watson is one of the fathers, if you will, of molecular biology. And I think this is where a lot of our problem lies, is that it was a field that was made from sin. And the sin that Jim Watson and to a lesser extent Francis Crick committed was that they needed physical data to prove a model that they had, a conceptual model that they had of the double helix. Recall that in Module 3 we talked about the collagen triple helix, and that was a structure that was discovered by an American chemist by the name of Linus Pauling. He later won a Nobel Prize for discovering vitamin C and the importance of vitamin C, and he's also famous for discovering the concept of electronegativity that we looked at in Module 2. So this is quite a guy, and Linus Pauling and his team were hard at work on the structure of DNA, and Watson and Crick very much wanted physical data which only they could get for validating the double helical model that they had come up with. Well, the person that had the data that they needed was an X-ray crystallographer by the name of Rosalind Franklin. You may or not have ever heard the name Rosalind Franklin. You've probably heard the names of Watson and Crick. Rosalind Franklin worked in Maurice Wilkins' lab. And Rosalind Franklin didn't like Jim Watson very much. In fact, she was fairly forthright about telling him she didn't like him very much, and the feeling was mutual. Jim Watson didn't like Rosalind Franklin very much. But she had the data that he needed. So he asked her, he said, Rosie, which was a name that she hated, Rosie, can I have your data? And she said, no, I'm working on it. It's not ready yet. It's only half baked. You can't have it until it's fully baked. And he said, well, I really need your data. And she said, I understand that, you insufferable tool, but I'm not going to give you my data. He went to Maurice Wilkins, her lab director, and asked Maurice Wilkins if he could break into the lab and steal Rosalind Franklin's data off of her desk. You may think that I made this up. None of these facts are in dispute. This is in Watson's own autobiography, his memoirs. So you know that everyone agrees on the facts of the case. So he went into the lab in the middle of the night, into Maurice Wilkins' lab that Rosalind Franklin worked in, stole her X-ray crystallographic data off of her desk. As it turned out, Rosalind Franklin died of cancer about 5 or 6 years after the events in question. She was not eligible to win the Nobel Prize, probably would have disputed whether she was eligible to win the Nobel Prize, and many people, including me, think that she was. But she died, and so that left the field open for Watson and Crick and now Maurice Wilkins to win the Nobel Prize. And that Nobel Prize was granted for the discovery of the structure of DNA. So this is what I'm referring to as the original sin of molecular biology. And Edmund Wilson, who had to work with Watson at Harvard, and others have described how difficult it was to work with Jim Watson. And this is the history of the field. This is the person who trained many of the other molecular biologists, and this is the environment that he worked in. And so a lot of your discomfort with molecular biology may have to do with the fact that it came out of this original sin. So before you beat yourself up too hard saying this stuff is difficult and I don't understand it and everybody in the field seems to be really difficult to work with and really difficult to understand, then it's not just you. In fact, it was me. And in spite of all that, in the 1970s when I went to college, I became a major in molecular, cellular, and developmental biology, and MCDB we called it, at the University of Colorado, and that's what I actually got my degree in 1980, was a bachelor's degree in molecular, cellular, and developmental biology. But I wouldn't say I really fell in love with molecular biology until I met the woman who would become my wife, who was a biochemist and molecular biologist by the name of Rosemary Hoffman. And Rosemary was the one who really turned me on to molecular biology and really showed me the beauty and the power of molecular biology. And I hope I can just take a fraction of that and show you today in the series of lectures that you're going to see the beauty and power of molecular biology.